Hello and welcome back. Today I have my lovely production assistant Eleanor. Say hi, Eleanor.
Hi.
And we're going to work a little bit more on these rules. Hopefully you've printed out this note sheet. You don't have to print out this note sheet, but if you don't, you won't have any notes. Now you'll notice I didn't give you any rules this time. That's because if I give you rules, you'll just try to work ahead and that'll mess up everything. So the first rule we're going to work with is just 3x, 3y. And what that's going to do is we're going to take these two numbers and we're going to multiply them both by 3. Notice that the x is still on the left and the y is still on the right. So they don't get rearranged, they just get tripled. 4 times 3 is 12, 2 times 3 is 6, 3 times 3 is 9, negative 2 times 3 is negative 6. Negative 2 times 3 is negative 6, and 1 times 3 is 3. And if we plot those over here, 12, 6 is right there. And whoops, 9 negative 6 is right there. And negative 6, 3 is right here. And what we get when we connect these points, don't think this should be a surprise at this point, but we get a similar triangle where everything is 3 times as big. This rule created a similar triangle with a scale factor of 3. Now, what if I used this rule? 1/2 x, 1/2 y. What do you think that's going to do to the shape? Well, you are right. It's going to take all these numbers, it's going to make them half as big, so 4, 2 is going to become 2, 1. 3, negative 2 is going to become 1.5, negative 1. And negative 2, 1 is going to become negative 1, 1/2. And negative 1, 1/2 is right there. And 2, 1 is right there. And 1.5, negative 1 is right there. And if we connect these points together, well, we get a little baby triangle now, don't we? And this triangle, this triangle is still similar, even though I kind of munched it up there. This triangle is similar, and the scale factor is 1/2. Let's try something different. Let's try x 2y. Okay, so now the x value, it doesn't change, but the y value gets doubled. What's this going to do to the shape? The x value, again, doesn't change, but the y value gets multiplied by 2. Now, do you think this is going to create a similar shape?
There's negative 2, 2 right there. 4, 4 is right here. And 3, negative 4 is right there. And wow, I'm really missing these points. Has something to do with the fact that I'm looking at the screen and not at the paper.
What I want you to notice here is that it stretched it a lot up and down. It made it twice as tall, but the width stayed the same. I did go from a height, I went from a height from negative 4 to positive to a height of 4 to a height of 8. Negative 4 to positive 4 being a height of 8 as opposed to a height of 4. But the width has stayed the same. Corresponding points are still in the same positions. It's just gotten taller. So this has made it taller, but not wider. And as a consequence, not similar. And I hope you can see that those things don't look alike, although this does kind of look like it's been spun around, but that's not really what's happened. Looking at these, what I want you to notice, in case you haven't noticed, is if I have the same coefficient for both x and y, I seem to be getting the same shape, just bigger or smaller. But if we stretch one more in one direction than we do in the other, well, then we get a distortion of the shape. Now, what if we add? What if we add, say, 3 to x, and just for the grins, let's subtract 4 from y? Will that create a similar shape? Well, let's just find these new pairs. Okay, what's 4 plus 3? Well, that's 7. And then y minus 4. Negative 2 minus 4 is, oh my, negative 2. Oh, what's this going to do? 3 plus 3 is 6. Negative 2 minus 4 is negative 6. Wow. Will this shape be similar? It sure doesn't seem like it's even close to the same positions, now does it? Let's see. Negative 2 plus 3 is 1. And 1 minus 4 is negative 3. Oh my, well surely this is going to be a dramatically different shape. Let's take a look at it. Well,
1, negative 3 is right there. 7, negative 2 is right there. And 6, negative 6 is right there. And if we plot these points and draw the lines, something truly surprising happens. Like,
it's the same shape, only it's moved. And how is it moved? Well, it's moved 3 spaces to the right and down 4. Okay, last example, and I'm going to be done for the day. And this rule is 2x plus 3 and 2y minus 4. Oh, that's a complicated rule. All right, so when x is 4, 2 times 4 is 8 plus 3 is 11. And 2 times 2 is 4 minus 4. Oh, 0. Ooh. 2 times 3 is 6. 6 plus 3 is 9. 2 times negative 2 is negative 4 minus 4 is negative 8. And 2 times negative 2 is negative 4 plus 3 is negative 1. And 2 times 1 is 2 minus 4 is negative 2.
so let's take a look. 11, 0 is the easiest one to plot, so I'll start with that. 9, negative 8 is right there. And negative 1, negative 2 is right there. Is this going to be similar? Well, again, sorry about my less than pretty lines.
But it sure looks like the same shape. But in addition to making it twice as big, I also moved it a little bit to the right and shoved it a little ways down. And I hope you can figure out how much of either of those. All right, homework tonight's going to be fun and easy. Enjoy.